The real moat that you actually land up building is with your software and its high integration with the specialized architecture that you're building. You create a moat around yourself. So that's how we are different from all the things that have been done previously. There wasn't sufficient market volume in any particular vertical for people to build custom silicon. Whereas we are moving forward, as you're seeing, whether it's in the consumer case or in enterprise or any of those things, there are many markets emerging that didn't exist before that create very high volume opportunities for semiconductor supplies. That then gives you the opportunity to build custom silicon that wouldn't exist today.
Hi, wherever you're listening to this, I hope you're doing well. Welcome to India Tech Report, a podcast dedicated to chronicling and supporting the growth of India's deep tech and climate tech startup ecosystems. I'm HrdWyr, and in today's episode, Ramamurthy Sivakumar, co-founder and CEO at HrdWyr, a semiconductor design startup in Bengaluru, talks about the company's plans after recently raising $13 million in Series A funding in an investment led by Ideaspring Capital. The company was co-founded in 2023 by Siva and Ganesh Guruswamy, both industry veterans, spanning companies including Intel, AMD, Sandisk, and Motorola, among others. In this conversation, Siva talks about how the era of custom silicon is upon us and what the AI-led opportunity represents. The company specializes in system-on-chip designs tailored for edge computing and applications including electric vehicles and industrial equipment. HrdWyr's first product, named Indus 1011, is expected to hit the market by the end of this year, Siva says. In August last year, the company had announced it had picked Tata Electronics as the packaging partner, and also that the Indian consumer electronics company Boat would be an anchor customer for the chip. Boat is to use this chip, which offers power management as a core feature in its truly wireless stereo charging cases. As many of you know, startups such as HrdWyr are getting funded in the time of a broader national push in India for semiconductor self-reliance, supported by significant government investment. Siva notes, however, that significant challenges also remain, including, in fact, the lack of timely and adequate funding at critical growth stages. Still, he thinks that the only way forward is to look at the aggregate of all the ongoing efforts, from startups such as HrdWyr to conglomerates like Tata setting up foundries and OSATs, as an opportunity to tap a $1 trillion sector and as a nation-building mission. Let's go. So Siva, thank you so much for doing this.
Yeah.
And quick context for our audience is that you've recently successfully announced successfully close of a Series A funding that you've announced. We'll get to that
Sure.
in a bit. And just to give the general audience a sense of what HrdWyr is, we can take a minute, just talk about a little bit about your background, how you and Ganesh got together, and the idea behind starting HrdWyr, and then we'll go from there.
The semiconductor industry, like all other industries, goes in waves, right? There are periods of time, there's always change, there's always innovation. And there are opportunities, those transitions in the industry always bring, right? Some transitions are pure technological transitions, other transitions are market transition. Other transitions are changing in user base with a lot of different types of things that happen. And my co-founder Ganesh and I have been in the business for close to 4 decades now, and we have cycled through many of these changes in the industry. And there was something fundamental happening that we noticed over the course of the last 4 or 5 years. That was getting subsumed by this whole idea of AI, right? I mean, everybody has heard of AI, and there is a set of transitions that have been driven over the last close to 15 years now. Some people start the clock at 2012, some people start the clock at 2014. Doesn't really matter, roughly 15 years or so. And much of that thing you think of as sort of the infrastructure building for this massive new transition that is coming, right? Some people are talking about it, but perhaps not as much as we should all have. And what we identified probably 3 or 4 years back is that we realized that virtually all of the semiconductors that we're using today, large class of semiconductors called SoCs or system on chip, those are the types of chips that are a full computer in their own rights. Right? Uh, we looked at the architecture of many of those and looked at directionally where AI was taking us. And those are discordance. There was certainly a suboptimal set of architectures and features that existed in that chip. So at the highest level, what we noticed was this probably a generational or even once in a few generational change that was going to happen with semiconductors. And we said, it's a great time to step in and do something about it. This was sort of our earliest thinking, probably about in 3+ years back. And that's where the genesis of HrdWyr was. I mean, there's a lot of things that go into the conversation, but at the highest level, we saw a strategic inflection in the market. And we said, where can we focus our attention? And that's how we started.
Uh, okay, just to delve into this, because it's a really interesting point, and you're talking about literally the raison d'etre for your company. So this transition and this inflection point, in what ways is it going to change things, for people?
Yeah. So I think the AI that we all use and a lot of people know that they're using AI, and there are more people who actually are using AI without knowing that they're using AI, right? Much of this we classify as what we think of as cyber AI, right? Things that process data and by and large displayed it on a screen for you. Maybe you heard some of it on your headphones or consumed it in some other ways. But by and large, most of the AI that people consume today, whether you use Gmail or you watch a YouTube video or you watch a movie on Netflix or a serial on Netflix, all of it has some component of AI that drives it. Much of that adoption was what one would call bottoms up, right? Consumers, without even knowing, started using AI. And then as they got used to some of the new features that came about, they started using it, benefiting from it, and so on. And much of the technologies over the last, decade or so have driven a lot of consumer behavior change and how we consume information, how we consume media, how we conduct our lives, how we order our food, or how we take care of our security. A lot of this adoption has been bottom up, and it has happened in a sort of massive way, right? And it's arguable that AI has had a much faster penetration than the previous big technology, which was the introduction of the mobile phone, right? AI's adoption has been much faster. Prior to that, a lot of people got used to using cellular technology or Wi-Fi technology. All of those things sort of happened at a certain cadence. But the bottoms up adoption of AI has been very, very massive. Now what is happening is that a lot of the transition of that is going into what we think of as physical AI. This is the same set of capabilities, knowledge, technology, all of that has been delivered to you for consumption in digital form. Now, many of those things are now transitioning into the physical world of actually changing behavior of physical things. So actually going from the realm of bits and bytes to the realm of atoms, right? And those changes are actually, some of it will get adopted the same way that cyber AI got adopted, which is bottoms up. People will see a feature, they'll use it. They probably don't know that AI is actually driving it. But what physical AI will get driven by is enterprise adoption. So there you are actually going to see a lot of tops down focus on the adoption of AI that we haven't seen so far, right? A lot of people went in, even in the enterprise space, just bringing AI tools and AI capabilities and all of that stuff. And happened because people in the organizations wanted to use it. But now boardrooms and CEOs and CXOs are now asking the question, where is my return? There is the real benefit. And the real benefit actually comes in the physical world, right? That comes through efficiency, that comes through safety, that comes through other features that improve, the human condition in the large sense, but really improve the balance sheet, right? So enterprises are going to ask the question of, what is the efficacy of the technology in which we are investing in?
So, in this context, where does the HrdWyr product fit in?
Yeah, I mean, the hardware product itself, the one product that we announced, it's a consumer product, right? It's think of it as a battery management, efficiency thing on the edge. We are getting off the ground, building our IP, building our team, building our capabilities, and when we looked around, our first thought was, how complex a chip can you actually build, right? When you start a new company, you have a certain quantum of investment, and you could look at that investment and say, I'm going to solve some really hard problem. With that investment, I don't know how far I'm going to get. Or you could say, okay, I'm going to solve a level of a problem that lets me go through the whole journey, right? Go through the whole journey of building a product, and maybe I'll get 100% of it done. Maybe I'll get 80% of it done. But let's try to maximize what we can do with the level of investment you had to start out with. We took the approach that we are building a branded semiconductor and chip that we'll sell to our consumers in an environment that is still pretty nascent, right? The ecosystem is still growing. There is a lot of things that have to come together for it to happen. And it's very risky if you start a program which will take you 20, 25, $30 million to build a chip, versus saying, okay, single digit millions of dollars to build a chip, but it goes through the full journey. And when you go through the full journey life cycle of building a chip, then what you'll end up doing is debugging the ecosystem. You see all of the different pitfalls that exist, gaps that exist in the capabilities that are needed for you to complete the product. And so far, we've been happy with the approach we've taken, and also the fact that we've actually been able to complete it.
Can you connect this to the earlier point you made about how, when you did a survey of the existing SoCs, you found some lacunas, and give us a sense of how the first chip that you're making addresses it in, maybe not all of it, but some of it.
Yeah. You're exactly right. That is you put the finger on the puzzle. Is that the first chip that you build doesn't necessarily incorporate all of the ideas that you can actually strategically see that some things going. At a fundamental level, if you take a step back, the transition I talked about is that most of the almost all of the SoCs that exist in the world today are built for a previous generation architecture, what is commonly called the von Neumann model of computing, where essentially you have an input, you do some processing in the middle, and you have an output, right? And it was very algorithmic. You have software in the middle that does it. What AI has done is to fundamentally put that on its head, right? Where you are not necessarily writing software. You're creating an initial model that gets trained on some basic pieces of data. But as you increase the efficacy and the volume of data that you have, the models continue to improve. So in some senses, the software gets built by itself, right? So that is the transition that we are going through when you are becoming data first or data centric in these architectures. And the existing SoCs don't necessarily accommodate that model. So fundamentally, the direction we are going is to build what we call AI SoCs that are AI first by definition, and allow us to build the chips that are needed for the future, right? And yes, we have incorporated a few of those in the first chip. Some of the ideas that we've tested out, a lot of it we are doing it in software to test out how well it works. But then, as we build that roadmap out, more and more of the eventual thought process we have on all of the AI SoCs that get built, will get into the next generation ecosystems.
Typically, what kind of end products would be ideally suited for the chip that you're first developing?
And as an end use case?
Correct. End use
Yeah.
case.
So the highest level definition, easiest way to describe it is any single cell lithium-ion battery can use our chip. Right? But a chip has a lot of tentacles, right? So at that very basic level, our very first publicly announced customer is Quote. They're going to be using it in the charging case for their TWS product. TWS is the technical term for the wireless Bluetooth headset that people use. So it'll go into the charging case of that product. But the way to think about that is any device that uses a lithium-ion battery to charge a consumer device becomes a target for our product. So go into other consumer devices like door locks and various things like that. You can strip out some of the functionality and use it in any semi-autonomous or autonomous small devices. There's not a very high powered chip, but that is the broad market into which we.
Tell us a bit more about this. I mean, explain the technical aspects, but maybe to a layperson, since you mentioned earlier on, efficiency is now very, very important.
Right.
So in the case of something like a Bluetooth charger or other devices, give us a sense of what's happening under the hood that we don't know about, which current chips probably are not doing. And then outside, as a person uses it, if there is any change in that way, or maybe charges faster or better, or makes the battery life last longer. Anything that comes to your mind?
I mean, those are all very good things that do get into this knowledge. So there's a number of things that start impacting you, then you start integrating products. So one of the first things we did was to reduce the chip count that goes into a device, right? So for example, most of the charging cases out there use 2 chips. We will actually be building it with 1 chip. That has an immediate impact on the form factor of the types of devices you can build. There are efficiencies that we are bringing in by knowing the profile of power usage in the device that will increase the ultimate battery life by 25-30%, right? And that has a direct impact on the end consumer, right? And those are the types of things that consumers will actually benefit from. But there's also a set of things that we will actually be able to do because we are looking very deeply into power usage in those kinds of battery powered devices that we feed back to our principal, to the OEMs that are going to be using our chip, that they can actually then put features and functionality even in the consumer applications that they use. So they could do things like, let's say some media that you're consuming is using a lot of battery, drain your battery down by 70%. They could say, hey, by changing this playlist or looking at some other type of media, you could listen for a little bit longer. You could listen for 2 hours longer. Let's say if you're on a plane trip or something like that. So a lot of features that we introduce, we don't directly take it to the consumer. We give it to the OEM, and then the OEM decides what they want to do with those kinds of things. So understanding the power profile and how the consumers actually use it has a tremendous amount of value to the end consumer because of the types of use cases that the OEM can bring in. I mean, this is a very simple sort of example for an average consumer who might benefit from the types of chips that we're building. And all this happens because we have not only a deep understanding of the power profile, but we have built models that will actually run on the edge and run very efficiently.
So at the sort of higher level, would you say that this reflects the bigger picture trend where folks like you are building a new generation of semiconductors, making semiconductor chips that are more versatile overall?
Yeah, I mean, when you use words like versatile, it actually takes you into a thought process of general purpose computing, which is what we've been doing for decades. Right? A lot of the capabilities that went into the data center over the last 15 years or so have been more general purpose processing, whether it's on the CPU side or the GPU side, primarily for training purposes, for training models on the data center, right? And there, your considerations have been the fidelity of the type of models that you create, because small variations can have a big impact on the model. So you have to have very deep analysis, what we call floating point compute, to a large degree on the data center side. And that is what these types of highly parallel architectures did for training models on the data center. The needs on the edge are very, very different. The needs on the edge are two things, right? Fundamentally, more and more edge devices will run on some kind of a battery, right? Which means you're constrained on power, right? At a very basic level. The number two thing is that as applications on the edge are becoming more mission critical, the most important thing that you need is very, very low latency and very predictable latency, right? You can't say that I want this little thing to happen on the edge, whether it's a semi-autonomous device of some sort, or a fully autonomous car, or some other thing that needs a very predictable latency for the response that you're going to get, but you're dependent on the cloud. You can't do that, right? So that is where the types of characteristics and the behavior you need from a semiconductor on the edge are very different from what the needs were during the era when you were training models on the data center. Not that those are going to go away. LLMs will always be there. We'll continue to build models, all of that stuff. But as that technology is now being adopted on the edge and all the myriad of use cases are getting generated, the requirements on the edge are very different from the requirements that's in the data center.
Okay. Can you talk about how your chip will do what it does, or what it's going to do?
Our chip is very simple at this point, right? The chip goes into a consumer device that manages the battery, right? And that's not a roadmap. This is not a single product thought process.
Of course.
Right? The same product is just a starting point, right? Because you had to prove that we can actually get a chip done, right? So you start with an architecture, you build the IP that is all needed, then you integrate that IP into an SoC, then you actually tape out, right? While these all sound like English sentences, each one of them is a highly complex process to get a chip to full tape out. A full tape out means then you actually go send it to a foundry that manufactures the chip for you, and then you build those things in millions of units of volume and you ship it out, right?
Yeah.
All these things seem very simple English sentences. Each one of them is a highly complex thing. The additional responsibility we took was that we are doing this in an environment that is still building the ecosystem around us. We are doing it in Bangalore, we're doing it in India. There's a lot of things that we've had to work through to complete that value chain, right? So I won't necessarily focus on the one chip that we've announced, right? It's a family of chip called Indus, which we've announced for a certain set of use cases. The real question is the thing that we have thought through as a roadmap that we are building. And we have two forces. One is the set of things that we want to do as engineers and things that we've thought through. But one of the ethos we've had in the company from the beginning is that when we start building a product, we have a strategic customer that is actually paying attention to what we are doing, right? So that gives us a sort of a real world filter for saying, okay, if you build it and this works and it makes sense for us economically, we have a path to the market. So that becomes a very important step in that process. And that's what we did with the first chip.
Yeah. I'm sorry, I didn't ask my question very well, but indeed, I was asking you about how Indus reflects the difference in your approach versus existing chips or in your philosophy, and which is reflected in the architecture. Again, if you can try and sort of explain it to a layperson, how the architecture that you have innovated, and I would imagine that's at the heart of your innovation.
Sure.
How that is different from existing chips that do the same things.
But, the way you want to think about that is that we have thought about the types of data that we are going to process as feedback that we are getting on the power profile, whether it is current or voltage or temperature, and how we then process that very efficiently on the edge in our chip, right? And there is some architectural details that we have done to actually process that. None of those types of things are commonplace today, right? They will become commonplace. Everybody else is building chips for the edge. A lot of people are building AI stacks. What we have done in the first generation product is a consumer level product, right? But what we will be doing moving forward as we go into the enterprise and all that, there'll be improvements in our AI engine that we built into our chip that actually processes this data. More importantly, in this business, your ultimate moat comes in two ways. One is you have the understanding of the vertical use cases that you're going into, right? The era of building general purpose controllers, general purpose chips that solved a lot of different people's problems with the same chip, that thing is kind of ending, right? As soon as you get into the specialized thing, saying that I'm going to have the special understanding of the workload and the type of data that is going to get processed, you're getting very, very verticalized, right? The real moat that you actually land up building is with your software and its high integration with the specialized architecture that you're building, you create a moat around yourself. So that's how we are different from all the things that have been done previously. There wasn't sufficient market volume in any particular vertical for people to build custom silicon. Where as we are moving forward, as you're seeing, whether it's in the consumer case or in enterprise or any of those things, there are many, many markets emerging that didn't exist before that create very high volume opportunities for semiconductor suppliers. That then gives you the opportunity to build custom silicon that wouldn't exist today, right? If you go to any large provider of microcontroller or other class of products, what they would have is a catalog, and the catalog products go solve a lot of different people's problems in many different cases, and they do some differentiation of software, right? What you don't have is that high integration between custom silicon and the software that works very, very close.
What might be a rough timeline for you to see this first chip into the market in the hands
So
of your customer?
we've already announced it to our customer last year. We taped out in January. Samples go out in the next few weeks, and then we should see these things hit the market by the end of the year.
You're already working on the next iterations or the next products in parallel.
Yeah.
Can you give us a sense of what you want to target next?
Well, I certainly wouldn't be very specific with you on that.
Okay.
There are, I would say, two ways to think about it. One is a roadmap of what we have already done, that we will continue to expand the markets. We have, higher powered chips that can go into many higher, larger batteries, larger current and voltage systems. There are basically fundamentally high powered systems. And then we are also looking at a number of other types of chips that take us into new areas in cybersecurity and various others.
What might be some of the most promising areas where you think your idea is?
I think there are no big surprises in this. I think the world that we are moving into is, if not even a fully autonomous world, you're at least moving into a semi-autonomous world. So there's autonomy in terms of devices, whether it is anything that is robotic, not necessarily a robot, but anything that is robotic, obviously becomes very, very interesting, because all of those things tend to need that high efficacy that I talked about on the edge, in terms of latency and performance. So we are not limited by our opportunity. We are not limited by the markets. What we are continuing to focus on is our model, which is we don't go commit to a particular chip until we know that we are about to market. So that we demonstrated with our first chip, which is until we had a strategic customer, we didn't want to commit to that product. So that model will continue, right? And that helps us in many different ways. One is obviously most obvious thing, which is somebody's sort of saying, okay, I'll take this thing to market, fits the bill. But more importantly, there is a feedback loop in that whole mechanism that helps us really fine tune the type of products that will hunt in the market, right? And that's a very sort of complex process that we go through.
And briefly, just for folks who might be interested in this, you've closed a Series A round of $13 million. How will it help you?
Well, we are primarily an engineering product company. Obviously, it helps us grow our engineering execution team, bring the type of talent that we want to bring in. And then it helps us with our products, right? Accelerate our roadmap with the products that you're already building, and then look at what is the next product line that we want to build, right? I mean, that's primarily the use of these.
Mm, mm. And you mentioned the ecosystem in which you have chosen to work in.
Yeah.
Setting up a team in India, specifically in Bangalore. So, can you give us a sense of what that implies? What are some challenges that you have to work with, and what might be some advantages? I mean, of course, anyone who talks about tech in India always talks about cost advantage of talent and things like that. But uh, in a field like semiconductors, where you require experienced designers and engineers and so on, probably not very sure to what extent that may be true. Uh, but give us a sense of what it means to be doing this out of Bangalore.
So we are headquartered in Bangalore, but I think of it as building it in India because we've got engineers in other parts of the country as well. The great advantage we have today is we probably couldn't have even done this 5 years back, which is tremendous improvements in EDA tools and other development ecosystem to do these things remotely. So today we don't need to have all our engineers sitting in the office or sitting in the same place. In fact, as long as they have the right high-powered laptops that we provide them to design their chips, they could be sitting anywhere. They could be sitting in a coffee shop. They could be on a plane. They could be sitting in their home office. It doesn't make any difference to us, right? And so that has given us a tremendous amount of flexibility in being able to recruit talent. The last thing we think about when it comes to talent is the one thing you mentioned, which is the cost of talent. That is, to us, getting the world-class talent that you're looking for to build the eventual product that you want becomes the most important thing. But what are semiconductors? Semiconductors are fundamentally a collection of IP that you integrate into a final product, right? So what we are heavily focused on is recruiting the right talent that allows us to build the type of IP that we need to eventually then put the product together, right? The all of the things that I've said to you takes us to this idea of a domain specific architecture, or DSA is the term that's used for it. And what domain specific architectures do is exactly what I was telling you, which is you move away from this genre of general purpose compute, which solves a lot of different problems, but then you do some fine tuning with software to where you're integrating the AI stack with the hardware architecture that you built. So what we were looking for is people who have tremendous hunger to go build the next generation of IP. So that is our first filter, right? Now, you asked me about challenges. Clearly, India has been doing semiconductor related work for 30 plus years. But by and large, there is a mature services industry here, the mature development centers of large MNCs. Now that has really helped the country build a lot of IP that is resident here, right? And that experience of actually completing IP and then bringing the IP together to a product that you've conceived, and the product conception I talked to you about, you don't sit in a closed room looking at a white space and decide what product you want to build. That ability to go interact with the ecosystem, understanding where the puck is going, where is the market going, where do your enterprise or consumers want to go. Those kinds of very primary understanding of where technology can go. All of those things, I think, are just at a pretty nascent stage in India, right? So the conception of how do you start with a white sheet of paper, but then narrow it down to a product that hunts is not an easy process. So that maybe a term I can use is the idea of product management, right? How do you conceive of a white space into which a product would fit? Those are things that I think are still developing here. So for us, we've had sufficient on-the-ground experience to know who in the ecosystem to work with. There are gaps that we continue to fill, but those are all the types of things that we deal with on a daily basis.
How many people in your team overall today?
We are less than 20. I think there are maybe 18 people or so.
Are most of them in India?
All in India.
You yourself, are you based in the US?
This is a semiconductor global business, right? So I spend half my time here, half my time in the US. But your customers are not just in India, right? Just so happens that our first customer is in India. Right? We are a global semiconductor business. So by definition, I have to be everywhere to win customers.
10, 15, 20 years down the line, what would you say is the niche that India can meaningfully occupy or even command?
I'm not sure that's the right way to think about it. Right? I think niche capability, niche thing, all of those kinds of things, by definition, are narrow. They might be deep, but they're narrow. Right? Those things might be appropriate for smaller countries. They may be appropriate for, I was going to name some, but I would avoid naming names. Maybe appropriate for a smaller economy, for a smaller country. The needs for eventually India's path is to be one of the top 3 large economies of the world. You cannot say that I'm going to be an expert in this one thing, right? Or even 2 things. We have to do almost everything at the same time. That is the complexities of this country. I shudder to think when people come up and say things like India should just focus on this one thing and India should not focus on large language models or something like that. We have to do things that this country is going to need over the next 20, 30, 50 years, right? And that is the entire basket of things. Now, what order you do it in, what capability you have, whether you're building the right educational infrastructure, which sadly we don't have today, those are all the things that I would worry about. Not trying to pick some winner, right? It is like picking a winning stock in the stock market, right? It's not a great game, right? You never know, right? How these technologies change. How semiconductors are built today are vastly different from what we did a decade ago, right? We could have not guessed where we are even 5 years back where we are today, right? So the way I think about this is that for a large country like India, there is not a single capability on the planet that we should not be involved in. We should do everything. How we do it, which maybe university or which region or which team or whatever focuses on a certain thing, that's a different question, right? It wasn't by accident that India actually is a world leader in space technology, right? It didn't happen by accident, right? It's because a set of people took a decision that we are going to go do that. Now, would you say that that's more important than water supply, right? You can't compare those things. So large countries like India have to be a leader in everything, right? Now, what order you do it, time will dictate.
I meant niche in the sense that specific to the semiconductor industry, 10, 15 years is still a very fairly short period of time, right?
Yeah.
So in that sense, so then first of all, what is the sort of timeline we should look at? I mean, space tech, we are a leader after 75 years.
I mean, it's okay. People throw these numbers without actually thinking about it, so I'm not going to react to that. I don't, you can think of specific areas and you can narrow it down and say, what do we do in that area? Yeah, then there might be an answer. Right. But when you think of something as large as the semiconductor industry, right? The semiconductor industry is expected to be $1 trillion industry in the next 10 to 15 years, right? That is not a small space, right? Semiconductor industry is not a monolith, right? There are probably 100 different types of semiconductors that get consumed on the planet. And what we ultimately use is a combination of a lot of that. A modern car could have 300, 400, 500 semiconductors in them, right? Not all are the same, right? There are everything from sensors to general purpose computing to memory to ASICs of some sort to controllers, all kinds of chips that go into these things. right? Now, if you think of a smaller domain, if you think of a university, for instance, and they have two professors that are, say, experts in some type of analog technology, yeah, they could say, yeah, we'll focus on this. But when you ask a question for the larger country, you can't do those kinds of focus. You have to have a much broader SWOT. And even in the 15-year time frame, because this industry takes a very long time to build, you can't wait 15 years to start something. That's why I feel like we've got to start with as many things as we can. And the beauty of India is that we have the talent to do it. There is virtually every aspect of that, what I think of as the end-to-end value chain, from a clean sheet of paper to a shipping product. There is not an aspect of it that we don't have people involved in from this country. So we can do it. And we have that unique position.
Okay, let's say to a large extent the talent is there in India, and it's getting better and better. And let's also say that policy is only going to get better. Let's hope that's the direction, and certainly it's the direction in which it's going. If one looks at all the RDI fund or semiconductor mission and whatnot, so then it boils down to things like growth stage money and more money at the Series A level and things like that. So when you look at that, do you think we can get to a point where we can look at much more ambitious projects? Like, for example, can someone take on building a GPU that can compete with NVIDIA in India? And what does that entail? Since you said we should look at doing everything.
Yeah, I mean, there's no reason to think that we cannot do any of those things. We can do it, right? You asked a lot of different things in the comment that you made. I'm trying to figure out which one to focus on. If you ask me whether sufficient capital is chasing the earliest stage of this, where there is the highest risk, the answer is clear no, right? There is no debate about that. Just the length of time it takes to raise capital for this type of a business, which has a much longer gestation period than what the investment community is used to, is much harder. So it does make it much harder. Are there people putting their hands up to try to enter the industry? Absolutely. There are lots of people who have ambitions. The thing that I would advocate is that people who are serious about this stuff figure out a way to build depth. There is a lot of superficiality that exists in the ecosystem. And I don't want to comment on what might be driving that. But this has to be taught at some level as nation building, right? If we don't change that mindset, and if you change the types of things that may be driving the capital towards the next e-commerce or the next app or whatever that gets built, that is fine. That is an approach that a certain set of investors will take, and that's nobody should deride that. But if you want to build strategic things, if you want to build things that have a longer gestation period, things that have a lot more depth, you have to think of these things as very different types of capital. So yeah, we are short on them. Absolutely.
In your own case, what are some things that really worked in your favor in successfully landing the Series A? And then maybe we can end with 10 years down the line, what sort of the vision for HrdWyr?
What caused somebody to write a check for us? You should talk to our investors about it, right?
Fair enough.
I mean, that is, before I was an entrepreneur, I spent the better part of the last 25 years being on the other side of the table, right? Looking at investments, looking at M&A, and looking at IP and things like that for a very large company. So what causes investors to take those decisions tend to be much more specific to the investors. The best thing that entrepreneurs like us can do is to put your case, the best case you possibly can, right? I'm not a great believer in these phrases that you hear about from Silicon Valley about fake it till you make it and all of those kinds of cliches. Those things don't work, right? So you have to try to create the best case for the type of thing that you're trying to raise capital for. I think we were able to do that in terms of the approach to the market we took, in our understanding of where the strategic trajectory was going in the semiconductor industry. Like I said, this transition to AI first chips, as well as domains of specific architectures. Then our demonstrated ability to have traction with customers. I think those are probably the things that was attractive to them. Clearly, my co-founder and our leadership team, we had close to 300 years of doing this, so that certainly helped. But it's very hard to give these two things positive to happen. It's very hard to do that. I think the second question you asked is about the 10-15 year roadmap. Ganesh and I got into this with that very clear mindset that this is not something we can do in 2 or 3 years, right? So you have to commit 10 to 15 years to make a real difference. So to me, real difference would be measured by, in that time frame, with the little bit of contribution that we are making, can we actually mature this ecosystem? Can we get to a point where India can virtually design an entire chip, with the talent and the infrastructure that we have here? And I think for us, the most exciting part would be is that the approach we have taken of building branded semiconductors out of India and then competing with the best in the world. There should not be any other company on the planet that we should not be competing against, right? And that is what we would like to do in the 10 to 15 years. But our real success comes if there are 50 other companies doing what we are doing, right? Just having one HrdWyr, yeah, fine. We created something successful. But if our work then triggers a lot of young people to go and take that risk, for the investment community to support that, and for customers like the OEMs and various other parts of the ecosystem to see that trajectory and say, yeah, we can use these products. That to us would be the bit.
That's it for this conversation. You'll find the relevant links to Siva and Ganesh's bios and HrdWyr's website in the show notes. To support my work, please subscribe to my newsletter at indiatechreports.in. I'm HrdWyr. Thank you for listening.